If you click on that link, you'll see all the classes that we've done. What I do, I have to record all the classes, send them to the same YouTube account, but then I set up playlists for each class. So this class playlist, it linked to that class only, so you don't have to weed through everybody else's. Okay. So all the classes that we've done so far are there. Why is the slideshow not coming up? There. No. Here we go. From I'd say the PowerPoint's a little bit behind the clicks. Here we go. I think. Man. Oh, and if you haven't noticed, Thursday afternoon they came in and put new surfaces on all our chalkboards and whiteboards. So, new deal. And we got a black screen with an arrow there, but not one here. PowerPoint is a wonderful thing, isn't it? There we go. I thought we did. Everything is running about 5 clicks behind, I think. Okay, I have a blue screen that has a white screen. Neither one of them is what we're... Okay, here we go. Now I have to change a few things here because this would not record well, or would that. That would, but you can't see it. That wouldn't. This should do it. All right. Yes. Now, oh, that's right. About to set up my projector. I usually like to do this before class. Something I was forgetting this morning. Okay. All right, I guess that's as good as we can get. Okay. Any questions on what we've done up till now? All right. Now, why do we mess with factoring? Well, factoring is used to solve equations. Equations are used to solve problems. That's what math's all about, is problem solving. So we're going to now use the factoring to solve some equations. How are we going to do this? One reason that factoring is an important algebraic skill is it extends our techniques for solving equations. Okay, up till now, linear equations were not too bad to solve. You isolate the x. But when you have quadratic and above, that's maximum exponent 2 or larger, you can't solve generally for a given variable. So each time we examine a factoring technique, we'll then use it to help solve certain types of equations. We'll need another property of equality before we consider some equations for which the highest common factor technique is useful. In fact, any factoring technique is useful. Suppose that the product of two entities is 0. Okay, picture that. We got one thing here multiplied by something here. The answer is 0. Can you tell me something about either one of these two entities? One of them's got to be 0. There's no way you can multiply two things together and get 0 unless one of these is a 0. That is a key thing. There's no other number in the world that's the case except 0. You thought 0 was a bunch of nothing. It's got a pretty important property there. Okay? This is, can we conclude that at least one of those numbers must itself be 0? Absolutely. Let's state a property that formalizes that, along with this property 3.5, along with the highest common factor pattern, provides us with another technique for solving equations. So here's exactly what we said before, expressed mathematically as a property. Let A and B, and they say, be any real numbers. I'm going to expand that. Any entities whatsoever. A and B are any two entities. Then if A times B is equal to 0, that can happen if and only if. Now, occasionally you'll see this abbreviated IFF, which if you were in the military, that's the identification friend or foe, the things they have on aircraft and stuff like this. That's not what they're talking about in math. IFF, if and only if. You'll also occasionally see something like this. Let me get my pen set up. Okay. So occasionally you'll see this abbreviated IFF, and also you'll sometimes see it done as a double arrow. Okay? What a single arrow says, something here implies that. If it's going the other way, something there implies this. The double arrow says this implies that, and this implies that. That's if and only if. Okay? So it's a double arrow. Okay? Just a little bit of nomenclature or symbology before we move on. So let's do example 5. There's an equation. Now before this, what were we doing? Simplifying expressions. You don't, well, you do sort of simplify an equation. What you do, what makes the difference between an expression and an equation? Equation. Equal sign, exactly. If you have an equal sign, that's an equation. But if you have an equation, you're trying to solve it. Find the solution. Find the values for that x, which makes that equation true. If you're simplifying an expression, you factor it, do whatever. And that's where you start here. What would you do first? Say again? Yes, factor out an x. And what does that leave you with? X plus 6. And that product is equal to 0. Now here's something else, a little time out. They set this one up for you very nicely because they set it up, this thing's equal to 0. If you ever have a quadratic or higher power in an equation, then what you want to do is get everything on one side, 0 on the other, so then you can factor, then you can use your zero product principle. No good unless that side's equal to 0. Okay? But they gave it to us at 0, so all we do is continue. Now, what did our property tell us? Here we have two entities, x times x plus 6 equals 0. What does our property tell us? Either x is equal to 0 or x plus 6 is equal to 0. Now, x equals 0, there's a solution right there. Done. We got a solution. I'm going to circle it. You don't have to, whatever. That's a solution right there. This one's not. Here's another equation. However, how does this equation differ from that? This one has a power of 1. Exactly. So what do we do with this one? Yes, we will isolate the x. Once you have a naked x there, you've got your answer. So how do we isolate the x? Subtract 6 from both sides of the equation, and this gives us x, that goes to 0, is equal to negative 6. Now, I'm kind of anal retentive when it comes to, I want to make sure I'm right. Okay, ask my wife. Okay, let's try and see if both of these are solutions. We suppose. See if they work. You put in a 0 here, what's 0 squared? Plus 6 times 0? 0. 0 plus 0 is? 0. Yes, that one works. We know that. How about negative 6? What's negative 6 squared? 36. Plus 6 times negative 6 is negative 36. 36 minus 36 is 0. You got it. So, those solutions work. Now, the book likes to write their answers in set notation. That's perfectly fine for me. I'm happy if you just do this, okay? But let's clear this off of the slide so we can go and see how they did it. Well, they copied it again, good for them. And then exactly like we did, because it's already set equal to 0, factor this side, and they did it correctly just like we did. And that means that either x equals 0, x plus 6 equals 0. Bingo, they got that right. And that then would be, they didn't show the steps here. X equals 0 is a solution, x equals negative 6 is a solution. I doubt if they show that. They don't. I like to always check it, make sure I'm right. Thus, both of these would satisfy the original equation. We checked to make sure. And the solution set, they like to write it this way. So in the back of the book, if you're checking your answers, this is how they'll do it. X equals -6, X equals 0. The two numbers and the only two numbers in the world that will make that equation true. Now, another timeout here. This equation here, what do we say about it? What's special about that equation? Second? It's got an equal sign. All equations have equal signs, right? It's what kind? What's the exponent? What's the exponent? 1. If you don't see a number, usually it's 1. Like you don't see a coefficient, that's 1, okay? One circumstance, we'll get to that later, when you don't assume it's a 1, you assume it's a 2. But that's something else, not here. So this is a linear equation, maximum exponent 1, and what we do, how many solutions did it have? 1 solution. This is a 2. How many solutions did it have? 2. Okay. Now, is that always true? No. But you can say this. This will have at most 1 solution. This will at most have 2 solutions. Once you find 2, stop. There aren't any more. That's the maximum number of solutions you can have. Is whatever the maximum exponent in the equation is. As long as those are whole numbers. Okay. Those are fractional. You don't have fractional answers. Okay. I mean fractional number of answers. All right. Good deal. Any questions on that? I'm sorry? Okay. The maximum exponent here is 2. So the maximum number of solutions you can have is 2. And sure enough, 1, 2. Maximum exponent here is 1. You can only have 1 solution of that. If the maximum exponent was 3, you might have 3 solutions, or you might have 2 or 1 or none. I mean, you may have no solution. Not really with 3, but okay. So you can have anything less, but you can't have any more than that maximum exponent. Okay? So this fit the bill. You got 2. Okay? Let's see what they go next. Oh, they skip. Okay, now these again are the old slides. This was example 5 in the old book, in the old edition. It's example 8 in yours. So let's do example 9. They skip example 9. So let's go to a white screen and do example 9. Solve this one. A squared is equal to 11a. First, what do you notice about this problem? It is an equation. It's got an equal sign. Ah, that equation doesn't have a 0. And we want it to. Why do we want it to? Because it has an exponent 2 or greater. Okay? If it had an exponent 1, hey, guess what? We're going to be fairly happy with it. But if it's 2 or more, we got to have a 0 on the other side. So how are we going to make that happen? Subtract 11a from both sides. Very good. Okay, what does the left-hand side now? A squared minus 11a. And on the right you have 0. That's what we want. Now what? Factor on the left. Factor out an a. And what do you have left? A minus 11 equals 0. Now what? Either a is equal to 0 or a minus 11 has to be equal to 0. What does that tell you? A is equal to 11. If you can see it, write it down. If you can't see it, add it. Add 11 to both sides. Isolate the a. Once you have it in a single power, add 11 to both sides. That goes to 0, and you have a is equal to 11. And guess what I want to do? Check it, okay? So let's do. Put a 0 in here. 0 squared is 0. 11 times 0 is 0. 0 equals 0. That works. How about putting 11 in here? What's 11 squared? 11 squared. 121, okay? And what's 11 times 11? 11 squared, which is 121. Okay, so those obviously work. Make sense? All right, good deal. They skipped example 10. So let's do that one. Solve 3n squared minus 5n equals 0. 3n squared minus 5n equals 0. Hey, they got away from mixing it up on us. They put it in exactly the form we want it. So what do we do first? Factor out an n, okay? And what does that leave you with? 3n minus 5. And that is equal to 0. What does that tell you? Either n's equal to 0 or 3n minus 5 is equal to 0. Very good. Now what? There's a solution. Say again. Add 5 to both sides because we want to isolate that n. Okay, so add 5 to both sides, and that gives us 3n, that goes to 0, is equal to 5. Now what? Divide by 3. Isolate the n, okay? And what does that give us? N is equal to 5/3. Oh, no, we can't have fractions, can we? Yes, we can. Of course, any real number would be a legitimate solution. So there's our two potential solutions. It's going to be a little messy, but we can do it. If you plug in a 0, I like this one. I can almost do it. What does this give us? 0 minus is equal to 0. Yes, we got that one. The next one's going to take maybe a little more work, and let's go and write it down. Okay? That would be 3 times n is 5/3, but then you're going to square that, right? Minus 5 times 5/3, and supposedly, hopefully, that's equal to 0. We don't know that it is, but let's see if it is. What is 5/3 squared? Now, you could do it that way, or there may be a little bit easier way. What does it mean, 5/3 squared? 5/3 times 5/3. Okay, make sure I get the h in there. 5/3 times 5/3. Okay, minus 5 times 5/3. And supposedly, we don't know for sure, that's equal to 0. Okay, now the reason I did it this way is, notice we can now divide out a 3. 3 over 3 is 1, right? And what does that leave us with here? 5 times 5 is 25 over 3 times 1 is 3 minus, and what do we have here? 25/3, and 25/3 minus 25/3, sure enough, is 0. So that was a little more work. Sometimes you might say, oh, that's not worth it. I don't want to mess with the fractions. Well, that's up to you. If you feel confident enough that your answer is right, I'm not requiring you to check it. I just say I usually check because I like not to make mistakes, but I do make lots of them. It's not that funny. Okay, now, let's see about example 11. Solve this one. 3ax squared plus bx is equal to 0. And we're solving this for x. Don't you love it when they have letters in there? Yes, okay. So we want to solve this for x. So what do you reckon we're going to do? Number 1, it's already set up equal to 0, so we don't have to do anything there. So what would be your next step? Factor out the greatest common factor, which happens to be an x. What does that leave us with? 3ax plus b, and that product is equal to 0. So what does that tell us? Either x is equal to 0 or 3ax plus b is equal to 0. Now we're wanting to solve for the x, so that's what we want to isolate, just like we got x equal 0 there. So what would we do? Subtract b from both sides. You just treat it just like a number. We don't know what number it is, but treat it like a number. Subtract b from both sides, and that gives us 3ax, that adds to 0, is equal to negative b. And now what? Solve for x. Divide out the 3a. And guess what that gives us? X is equal to minus b over 3a. Now, we don't know what numbers they are, but there's some numbers. Now, let me tell you this. What number cannot be included in one of those? You know. B can be any number in the world. That's a hint. Any number. Any real number in the world, no problem. How about A? Say again? Okay, it could be 3. No sweat there. What can A not be? What can you never do in division? You cannot divide by 0, so A can't be 0. That's one thing you can write down right now. I bet you they don't do it in the book, but I'm going to write it here. A cannot equal 0. But guess what, folks? If A were equal to 0, that term would be 0, wouldn't it? Okay? And then you'd have bx is equal to 0. And guess what? Either b is going to be 0 or x is going to be 0. So if b can be any number in the world, then the x would have to be 0. So that would give you only one solution, and that wouldn't even matter. Okay? So sure, a can't be 0, but that's beside the point. Okay. Yes? I'm sorry?
So let me ask you a question.
Surely.
At the beginning, like in the book, you got 3x squared plus bx equals 0.
Right.
Then you got there like it does equal 0.
I've got what?
That line, that 0, is that 0? You make
Okay, no, I said A is not equal to 0. Okay? A cannot be equal to 0. How do I know that? Because x would be minus b over 3a. You can never divide by 0. So that means that A can't be 0. But then we look over here. If the A were 0, then this term wouldn't even matter. You wouldn't have two solutions. You'd only have one, and that would be x equals 0. So if A were 0, you don't have but one solution. If A is not 0, then you have two solutions. That's the key. Okay? Now, I know y'all want to check it, don't you? Sure you do. Okay? I'll do the first one. What's this one? 0 plus 0 is equal to 0. Yeah, that was easy. Now the next one. X equals negative b over 3a. Let's plug it in, plug it in. That would be 3 times a times negative b over 3a squared plus b times negative b over 3a equals 0. Plugging in that x into both places where you see x is above. Now, I kind of like doing it the way we did before, but if you want to do it another way, we can. Okay, you want to just, okay. Say again? Okay, all right. It's not that bad. Okay, but anyway, 3a times minus b over 3a times minus b over 3a. Okay, that's what minus b over 3a squared means. You multiply it by itself. Plus b times minus b over 3a equals 0. Okay? Now, what do you notice you can do in the first term there? Divide out of 3. That's 1 and 1. Divide out an a. That'd be 1 and 1. And what does that leave us with? What's minus times minus? Plus. Okay, so we'll get rid of those. And what we got left in the numerator is b times b, which is b squared, over, and what do we have in the denominator? 3a. Plus, and what do we have over here? Yeah, b times a minus b, that would be a minus b squared over 3a. And sure enough, you add those two together, you do get 0. We didn't know these before. Now we do. What are you doing? Okay. Okay. It's eating my white screen. Okay. I don't know where it went. Okay. Let me see if I can get it back. Screen, white screen. Nope, it's gone and not forgotten. Okay, sorry. This thing does this periodically, and I can't retrieve it. Sorry. Hopefully you got that as we were doing. We checked it. It worked. There's our solution. All right. Any questions on that? All right. Now, wherever it put my white screen, I don't know. But now I have to, believe it or not, they call it unwhite screen. And that gets us back to here. I don't know. Strange nomenclature. All right. Any questions? So let's now solve some word problems. That's why we want to do equations, so we can solve some word problems. Y'all all love your word problems, right? Yes, of course. Okay? They're not that bad. Okay? Now this calls it example 9 on the old set. This is example 12 in the new edition. See, the new edition has a few more examples in it. Okay? The area of a square is 3 times its perimeter. Find the length of the side of the square. I thought we did too. Why have y'all been letting me run on and on and on if we'd already done these? All right. Somebody moved my things to the wrong part of the book. Okay. All right. I've already given you the homework exercises for this too, haven't I? Yeah. So, okay. Did we? Oh, I see my mark. That's where my problem was. Had 2 marks on the page. I didn't erase one of them. Sorry about that. We were here. We were on example 13. I don't think they have example 13. Let's see. I thought all these things sound familiar. And y'all just let me run on and on and on. Say again? Well, that's good. That's the reason I did it. I planned it that way. Yeah, right. Okay. All right. Let's see. See, I'm teaching a Math 112 class, and they're doing similar stuff, a little bit more difficult. I thought, wow, these are awfully similar problems to what we did in 112. It wasn't in 112. Sorry about that. See if I can get the white screen to come up again. 113, we had done the cylinder, right circular cylinder. Remember that? Okay. We ran out of time, but here's what we had. Hopefully most of you have your books. If not, look on with somebody, so I don't have to write this down. The volume of a right circular cylinder is numerically equal to the total surface area of the cylinder. That's what we had done. The volume of a right circular cylinder, we found out was, and I think we had done this. Oh yeah, if the height is equal to the length of the radius. That was what we did, remember? And this problem is very similar to the one. I'll draw it again, and again, my dimensions aren't very good. In fact, they stink, but, you know, get over it. Here is the radius, and this is supposed to be the height. And those are supposed to be equal to each other, R equal H, okay? And we had the volume of that right circular cylinder, that's the same R down here, supposedly, is the area of the base, pi r squared, times the height, but the height was also, the H is equal to R. So we had pi r cubed. That's the volume of that right circular cylinder is numerically equal to, so it's equal to the total surface area. And we did that, remember? When we did the total surface area, we had, and I'll do that here, 2 pi r squared, because that's the top and the bottom. And then we cut this can down the middle, laid it flat, and it was 2 pi r, that's the circumference of that circle, when you laid it flat, times h. But h is equal to r. So this is 2 pi r squared. So we had 2 pi r squared for the bases, 2 pi r squared for the surface area, for the lateral area. So that was equal to 4 pi r squared. We did all that last time. Remember? We didn't?
No, we just got
Okay. So we got to here, right? So this is the surface area of the bases, the top and the bottom. pi r squared is the top, pi r squared is the bottom, so 2 pi r squared here. And this is 2 pi rh. That's what we got last time. But since h is equal to r, this is also 2 pi r squared. R times r is r squared. So we got this plus this is equal to 4 pi r squared. Total surface area of 4 pi r squared. See it? Okay? That's our equation. Now we have to solve it. The hard part is getting all set up. The easy part is solving. How do we go about doing that? And oh my goodness, we have cubes in here. What are we going to do with those? Well, not bad. What would that give us? What would you do? Pi is a number, just like 4. Second? Okay, yeah. So the exponent, you notice, is 2 or more, right? So what does that mean we have to do? What's our technique? Get everything on one side and 0 on the other. So that's our next step. How do we do that? Subtract what? 4 pi r squared from both sides of the equation. Okay? What does that give us on the left? Pi r cubed minus 4 pi r squared is equal to 0. Got it. Now what do we do? Factor out your greatest common factor. And what is it? Pi. It's a pi in both. And r squared. And what does that leave you with? Okay, yes. Where? Oh, the greatest common factor? This is pi times r times r times r, right? This is 4 times pi times r times r. What's the greatest common factor there? Well, both of them have a pi, so that comes out. This has r times r times r. This only has r times r, so 2 r's, so that's r squared. That's your greatest factor. What does that leave you with in the first term? R and r alone, okay? Minus 4. And that's equal to 0. Okay? Next. Either pi r squared is equal to 0 or r minus 4 is equal to 0. Very good. Now, actually, this is a factor of 3. Pi times r times r. So either pi is equal to 0, and guess what? Pi is not equal to 0. Pi is 3.1415, blah, 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 blah. It goes on forever, okay? It's a number greater than 3. So that can't be 0. So the only option then would be r equals 0, right? Okay. So pi can't be 0. What you can do, you can divide both sides by pi if you want to. And that gives you r squared. And what's 0 divided by pi? 0, okay. So this means that r is equal to 0. Okay, now, time out. Can you show me a can whose radius is 0? No, it's not there. There is no radius, okay? So, and the height is also 0 because the radius is equal to the height. So it's not there. So this is a meaningless solution in the real world. It's mathematically a solution, but it doesn't happen. There's no right circular cylinder with a radius of 0 or a height of 0. It just doesn't exist. So that leaves us with r minus 4 equals 0. And what do we do with that? Add 4 to both sides, and that gives us r is equal to 4. Now, did they say what units these were? No, they didn't. Whatever units they are, inches, feet, miles, furlongs, whatever they are, meters, or whatever. That's the radius, that's also the height. It could be 4 inches, there's your can. Does that make sense? Okay. 0 is not a reasonable answer because you can't have any right circular cylinders with no radius. So your only answer there is 4. All right, that's where we left off. Sorry about that. So, homework exercises here. Do either 1 or 3. You've had those before. Any of the odds, 5 through 41, you've had those before. Any of the odds, 43 through 63, you've had those before. Any of the odds, 65 through 79, you had those last time. Any of the odds, 81 through 85, you had those last time. And then the word problems, any of the odds, 87 through 95. Okay? You don't have to do them all, but do enough until you get really comfortable and say, man, I'm liking these, okay? Then quit. No. I mean, you can do as many as you want after you start liking them, okay? All right, any questions then? Sorry.
Page 150, right?
What's that?
Page 150.
That was on page, 150 and 151, yeah. Okay? Now, if you really find these very boring and want to do something a little tougher, you can do for further investigations, but I'm not going to assign those. But you can certainly give those a shot. I'll help you if you have any questions. Now, they had, oh yeah, I should have pointed this out too. At the top of page 150, they have a concept quiz. And these are things that are all true-false questions, okay? Let me just warn you, you're not going to see a true-false question, or not many of them, on any quiz or any test. That's just typically not my style, okay? Because there's so many ways you can write a question, makes it so confusing you don't know which the question's about. And so I don't like true-false questions. However, this is quizzing you on the concept, so it's not a bad idea to read through these, figure out whether you think they're true or false, and then turn a page and see if you've got it right or not. And if you don't have the concept right, you might want to go back and check on it. So the concept quiz is up to you, okay? Now, if you all want to do those in class, we can, but we're going to really need to move on some. So, any questions? All right. Yes. No. My tests are working problems, just like the homework. See, I don't want to give you something I haven't given you in class. Now, the final exam, by the way, let me go over that in case I didn't do it before. Final exam will be 2 parts. The first part will be, and it's a 2-hour final or an hour 50-minute final, so plan for that. It's departmental, that's why I know it's true. The first part of the final exam will be multiple choice, 30 multiple choice questions, okay? But you solve them just like we do here, but then pick out the right answer rather than writing down the right answer, okay? And then the second part will be 8 questions, more like what you see in the book, and I assign you for homework, and you have quizzes and tests. And those, the 30 multiple choice will be 2 points each, 30 times 2, 60. Y'all are good at math, okay? And then the 8, fill in the, write out the answer questions, 5 points each. 8 times 5 is 40, 60 and 40 is 100. So that's going to be your final. That will be part of it multiple choice, 60% of it multiple choice. But I don't like multiple choice generally. Yes? What's that? When it's what?
First quiz.
I think here.
First quiz.
First quiz. Oh, when we get through, we've done 3-4, 3-5. When we finish 3-6, that'll be the first quiz. It'll be around 10-ish. Okay. Yeah, about 1 page. Fill in the blank question. Yeah. Huh? Well, I give you the problem. I have an answer blank here. You fill in the answer blank. Yeah, I'm sorry. That doesn't sound right. All right. Good. Now let's see.
Excuse me, I understand that we need a calculator, but is it possible to use our cell phone for a calculator?
That's fine with me. I don't care. Okay. You just can't call your friend and say, what's the answer? Okay. None of that. Yeah, you wouldn't dream of doing that, would you? Okay. Why did I mention it? Okay. I can't get the cursor. There it is.
Were you doing the reviewing for this quiz?
We're reviewing now. That's why I ask, are there any questions? I ask it over and over and over. So if you have questions, ask. That's your review. Okay. All right. All right. For some reason, here we go. Yes. Say this again. Okay. Okay. If you go down the hall here, this long hallway, you'll see two exit signs hanging from the ceiling, okay? The first one goes down, then the second. At that second exit sign, about 2/3 of the way down the hall, don't take a left and go down that thing. Take a right. That room right there is 202, I believe it is. 202, and Miss Monchelle Hollins is in there. She is fantastic, and she will find you a tutor. If she doesn't have one right available, she'll get one. And it's absolutely free. That's for everybody, okay? Student Support Services. It's a federal grant that we have, and you get it for free. All right. What I need to do here is get out of 3.4 and go to 3.5. Well, PowerPoint is dreadfully slow today. Why is not? Oh, there. It's trying to respond, but it's quivering a lot. Okay.
So we'll have a quiz when we get through with all the
3.4, 5, and 6. When we finish 3.6, you'll have a quiz on those first three. Then when we finish the rest of chapter 3 and I think 2 or 3 sections in chapter 6, then we'll have the test after that. It'll cover the first 3 sections and the last 3. So the quiz, you'll be quizzed and tested on the first 3 and just tested on the last 3. All right, now we go to the slide. Okay, from current slide. All right, chapter 3 again is talking about polynomials, if this will ever come up. Yuck, this is so slow. Okay, I still got to get rid of this and that, and that. All right, still talking about polynomials, many names, many terms, okay? Now what we're going to do is factoring a few other types of things. The difference of 2 perfect squares and the difference or sum of 2 perfect cubes. That's what we're going to be doing. So the first we're going to factor the difference of 2 squares, and then we'll factor the sum or the difference of 2 cubes. Then we'll use factoring to solve equations just like we did before, and we'll solve some word problems that involve factoring. Okay? So good deal. Now, let's start here. Back in the first, either chapter 1, chapter 2, or the first 3 sections of chapter 3, you reviewed some of this stuff, and I said that was on your own, okay? And one of the things we did was multiplying certain special products. And here's one of them. A plus B times A minus B. That's called the sum times the difference of the same 2 entities. Does anyone know what the answer will give? Don't read my hand. Okay. What will it be? A squared minus B squared. She reads my hand really well. Okay. But we could have foiled that and found the answer, right? Let's do that. A times A is A squared minus AB plus AB, that adds to, and then a minus B squared. So minus AB plus AB adds to 0, so it's A squared minus B squared. Yes, you knew that without reading my hand, okay? That's always true. Anytime you multiply the sum times the difference of the same 2 numbers, guess what we get? The difference of their squares. So guess what factoring is? Undoing multiplication, right? So now we can say, if I say factor that, how can you factor it? A minus B times A plus B. We know how to factor that already because we just did that. The same pattern viewed as a factoring pattern, reverse the size, is referred to as the difference of 2 squares. Anytime you have the difference of 2 squares, you can factor them as, and again, A and B just don't stand for any numbers, any entity. Okay, any entity, A squared minus B squared, you can factor A plus B times A minus B. Applying that factoring pattern is fairly simple, and we'll do the next example, which has, I think, multiple parts. Okay? That first one, A. Whoa, let me get my pen back. Okay. Got it. X squared minus 16. Can you factor that? How? X minus 4 times X plus 4. Fantastic. Okay, that was the A part. Does everybody see that? Because 16 is the perfect square of 4, right? So it'd be X squared minus 4 squared. Okay, now, notice he likes to give the minus first and the plus second. It doesn't matter, because multiplication is commutative. It doesn't matter what order you multiply. 7 times 3 is the same as 3 times 7. It doesn't matter which order you do it. Okay, let's go to the B one. What would the B one be? Can that be done? How? It's what? A little louder? 2x minus 5. See, you started a trend here. Times 2x plus 5. Perfect. Y'all are so good. Okay? How about the C one? Can that be done? How? 4x plus, he said plus. Okay, got it first. Okay, well, 3y times 4x minus 3y. It doesn't matter which one you say first. Okay, how about D? Can that be done? Can that be done? 1, say again, plus A times 1 minus A. And guess what? If you're ever in doubt, go to multiply with the other, see if you get that solution. You will. It works. Okay? Now, so a few of you may be pausing or struggling. Here's something that would not be a bad idea to do, in this section especially, but anytime. Let's just call it N. Write down the numbers from 0 to 10. Whoa, I didn't leave enough room, did I? Now, I want you to square those. What's 0 squared? What's 1 squared? What's 2 squared? 3 squared? 4 squared? 5 squared? 25. 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 100. Actually, you could do 11 and 12 too, probably, because you know those pretty well. I think we did 11 earlier, okay? Now, for what's coming up later, let's go on and do N cubed. I know the real easy way to do that, if you've done this, multiply N times N squared. That works, right? Isn't that N cubed? So multiply 0 times 0 and you get 0. Multiply 1 times 1, you get 1. Multiply 2 times 4, you get 8. 27. 64. 125. You know, much bigger than that you don't usually mess with. But you could do them. Or you can get out your little black boxes and do 7 cubed or 6 cubed. It'll give you the same answer. But this one you can do, at least they're there almost in your head. Okay? But you can fill out the table as far as you want to go. Those numbers get really, really big, though, the cubes do. Okay? So get to know them, okay? Get familiar with these, okay? Recognize them as perfect squares, okay? We won't be using the cubes until a little bit later. All right, let me clear the screen. Can I go on and clear this, or do y'all need it up there a little longer? Huh? No, some people are still writing. Let me clear this out of the way. Y'all can fill in the rest of the table if you want to. You can go past 10. You can go fourths and fifths, and I don't care. You won't need them, but you can do it. Okay? Okay? All right. Then let's erase all ink from the slide, and let's see how they do it. Now, they take a few more steps, but y'all are so quick you didn't need to. this is the same as x squared minus 4 squared. Okay, you did that in your head, and then you found that to be x plus 4 times x minus 4. Exactly the same. Doesn't matter which order you write them. Okay? And then for the B one, 4x squared minus 25. If this is helpful to you, write it this way. The 4 is a perfect square of 2. X squared is a perfect square of x. So that's 2x squared minus 5 squared. And then you can then write this as 2x plus 5 times 2x minus 5. And again, the order doesn't matter. But y'all did it right off the top, so y'all are quick. A lot quicker than these guys are. Okay. All right. Got it? Let's do C. They wrote that as 4x in quantity squared minus 3x quantity squared. That'd be 4x plus 3 times plus 3y times 4x minus 3y, whichever order. And then this one, which I'll pause a little bit, notice that 1 squared is 1. Okay, so that would be 1 squared minus a squared, so it's 1 plus a times 1 minus a, in whichever order. Got it? All right, any questions? Let's do example 2. Well, no, they have a little bit. And this is what I was already saying. Multiplication is commutative, so the order of writing the factors is not important. So you could have written that x plus 4 times x minus 4, x minus 4 times x plus 4. It doesn't matter. We already went over that. You must be careful not to assume an analogous factor pattern for the sum of two perfect squares, because there is no way to factor. No way to factor. You can never factor x squared plus 4. You can't do it. Don't even try. There is no rule. Only the difference of two perfect squares. For example, if you were to be tempted, what would be your temptation to say here? X squared plus 4 would be? Times? Oh, okay. X plus 2 times x plus 2. Let's see what that gives us. Can we FOIL that? Okay, what would that give us? X squared plus 2x plus 4x. That's not what you got here. You have an extra plus 4x in it. So no, this does not factor that way. There is no way to factor x squared plus 4. No, there's plenty of others. But the sum of two perfect squares you can never factor. And let me put this in the real number system. If you go to complex numbers, which I'll mention, but you're not responsible for in this course, that's not. Because you see, when you do multiply those two together, you have the extra term in there. That's not it. Now, that is an important thing. This is x plus 2 squared. That's what your answer for that is. Okay? We'll get to that in a little bit too. When you see a form like this, you can then write down the answer pretty quickly. We say that a polynomial such as x squared plus 4 that has no factorization, we call it a prime polynomial. Just like a number like 13, you can't factor that. That's a prime number. Well, a prime polynomial. I don't know. Any of you read the Reacher series, Jack Reacher? Yeah, he's good at prime numbers, isn't he? He uses those all the time. In fact, he's great. Really good at math. Okay. So if you ever need that kind of stuff, you need to be good at math. Okay. Or that is not factorable using integers that we call prime. Okay, sometimes the difference of two squares pattern can be applied more than once. So you keep doing it until you run out of anything that will factor. Okay? In fact, this is a rule for later too. Always when you think you're through factoring, you say, can I factor it any further? Okay? So, it is possible to apply both the technique of factoring of common monomial factors and the pattern of difference of two perfect squares in the same problem. In general, it is best to look for the common monomial factor first and then do everything else. Okay? If they skipped some things, I think they did. Yes, they did. They skipped example 2 and 3. So let's actually go back a slide and then go back to our white screen. Why this is scooted over to the left, I don't know. Oh, there it is. All right. So let's do example 2. X to the 4th minus y to the 4th. Can you do that? What's that?
I ain't worked it out yet, but I think you can do it.
Okay, he has confidence we can do it. That's good. Okay, yeah. This is the perfect squared. That's x squared squared. This is the way the book does it. Minus y squared squared. So then what would be the factorization? X squared minus y squared times x squared plus y squared. Very good. Are you through? No, why not? No, there's no equation here. But yeah, look at this. That's the difference of two perfect squares. So keep factoring until you can't factor anymore. So what would that be? X minus y times x plus y. And can you factor the second one? No, you can't. That's the sum of two perfect squares. You can never, ever, ever factor the sum of two perfect squares. That's x squared plus y squared. All right. That was Bueller the buzzer, by the way. You know. Okay. That's now completely factored, right? I don't know what this sounds like on Screencast-O-Matic. It's probably really weird. So if you're listening to it at home, watch out for your kids saying, "What are you doing, Mom?" You know, yeah, okay. All right, let's do the B one. 16 x to the fourth minus 81 y to the fourth. Can you factor that? How? Okay, you notice this is the perfect square of 4x squared minus 9y squared squared. Perfect. Now, how do you factor that? Can you? Wait, not yet. Do one step at a time. One bite at a time here, don't? Yeah. 4x squared plus 9y squared times 4x squared minus 9y squared. Are you through? Why not? The second factor is, again, difference of two perfect squares. So what do we do first? Oh, how about that first one? Can we factor it? Did I hear a yes? It's the sum of two perfect squares. Guess what? You can never, ever, ever factor the sum of two perfect squares. Forget that one. It's still a factor, though. 4x squared plus 9y squared. But can you factor the second one? Yes. What will that factor? 2x minus 3y times 2x plus 3y. Done. Way to go. Y'all got it right. And they got it right in the book, too. Good for them. All right. Oh, no. Don't tell me we're through. We're just beginning to have fun, but we're always have fun. Okay, homework exercises here. You can do any of the odds 1 through 25, which is a perfect square. Oh, wait. Let's see. Nah, let's just do 1 through 17 for now. We'll do 19 through 25 after we do the next exam. This is page 157. That's odd numbers 1 through 17. Good deal. Okay. The previous was 150 and 151. I had already given all those in 150, so the new ones are on 151. On that earlier, not counting the ones I told you before, the new ones. Okay. Okay. Good deal. And you can always listen to Screencast-O-Matic. They're on that too. All right. Good deal, folks. Oh, this is so weird, isn't it? We just meet the first time this week and I say, have a good weekend. That's so bizarre. Don't y'all want to meet on Friday so we can have two questions? Oh, shucks. Okay. Oh, man.